This production is brought to you by the University of Edinburgh.
Hello, and welcome to an interactive introduction to MATLAB. This screencast will walk you through the solutions to exercise 8, which focused on using for and while loops. Question 4 is all about calculating the factorial of a non-negative integer using a for loop. You can see that I have created a script with some comments at the top which relate to the next few questions. In the variable dictionary, you can see a variable called n, which is going to be the number the user enters to get the factorial of. I have a vector x, which will start at 0 and range to n minus 1. And I have a result variable, which will hold the result of the factorial calculation. Next, we add a command to get the number from the user. To do this, we use the input function we've used before and assign it to the variable n. Later, we will modify this script to check whether the user has actually entered a non-negative integer. But for now, we will just assume that they have, and we will move on to complete the calculation of the factorial part using a for loop. Firstly, we define the for loop. Define our loop counter x to range from 0 to n minus 1. If you look at the factorial algorithm, you can see that each term that is multiplied together is n minus 0, n minus 1, n minus 2, all the way up to n minus 1. Our loop counter is essentially providing the term for n from 0 to n minus 1. Our result will therefore be the result from the previous iteration multiplied by our n minus our loop counter variable x. We use the display command to display the final result. As usual, we also need to define our result term. We now run our script, adding a value of 5 for the non-negative integer input, which produces an answer of 120. This is the right answer and shows that the factorial algorithm is working. We now return to a previous part of the script to alter it so we can test whether the user has input a negative number or not. To do this, we use an if and an if-else statement. So, if n is less than 0, then an error message must be displayed. This is the test for the case when n is less than 0. But we also want to test for a floating point number. To do this, we use the MATLAB function floor. You can check the help file for information about floor, but essentially the command floor rounds down a floating point number to its nearest integer. The else if condition is going to be if n minus floor n does not equal 0, then we must have a floating point number, and we will display an error. And if none of these conditions are true, then we must actually have a positive integer. So we'll add the else statement, and we'll leave the rest of the equation alone, only adding another end to complete the statement. Finally, I can tidy up the script by selecting all and choosing Smart Indent. And you'll see that MATLAB has just indented our factorial calculation so that it is easy to see that it is part of an else condition. Running the script and entering a negative integer, we get the correct error message. Resetting, and running again, entering this time a floating number, It again returns with the correct error message. Lastly, we can check the result again for a positive factorial 5, which works too. Question 5 is all about using a while loop to calculate a series that approximates an exact value. The idea is that we will use the while loop to calculate a number of terms in this series. And when we have enough terms to get within 0.01% of the exact value, then we want our while loop to stop. You can see I have created a new script with a new list of comments. And in the variables dictionary, I've defined a variable called sExact, which is the exact value we are aiming for. I've defined a tolerance, which is how close we will get to the exact value before we stop. N represents the number of terms in the summation, and the result just holds the results of the summation. I've defined the exact value, I've defined the tolerance, and you'll notice that I've converted the percentage tolerance that was given in the question into an absolute value. Now we are ready to construct the while loop. The condition for the while loop stopping is when we get within the tolerance of our exact value. I'm using the ABS function here, which takes the absolute value of whatever is in the brackets. This is because we don't know whether our summation is going to approach the exact value from above or below, and that should be greater than our tolerance. Whilst that is true, that the approximation is greater than the tolerance, then we want to continue taking terms in our summation. When our summation becomes the same as or less than our tolerance, then we should stop. So our result is simply the value of the result before plus 1 over n squared. We then increment n. We also need to define n and result before we start our while loop. The last thing we need to do is use the display command to display the final number of terms required. You'll notice that I've typed n minus 1 as the number of terms required. This is because n is incremented before the loop condition is checked again. Running our script, we can check whether it works as expected. It tells us that 6,079 turns were required to get within the tolerance range of the value.
This production is copyright the University of Edinburgh.